Yep.
So a little bit of background about myself. I'm currently doing research for the College of Engineering and Artificial Intelligence, so I'll explain it over here. So yeah, when people think of AI or hear the word AI, they think of Terminator, or like Skynet, or like some crazy killing robot machine that's gonna take over the world. I'm here to tell you it's not that. So what is AI? AI actually has a loose definition. The favorite definition that I came across recently was by a technologist by the name of Ed Burns. He says that AI is the simulation of human intelligence by machines. So basically any technology that can make decision making like a human is considered AI. You actually interact with AI on a daily basis. If you ever unlock your phone with your face, that's an AI making that decision that it's you. Even something as simple as like a Google search. AI is deciding what results to provide you based on like your location, what previous searches you've done. Even something as simple as like a traffic light. If there's a camera on a traffic light and it sees a car's coming, it's an AI deciding to turn that light green. So yeah, shedding some light on the term itself, AI is actually an umbrella term. If you look down there, there's a bunch of different subfields that AI covers. And so I'll only be going over a couple, such as natural language processing and computer vision. And then at the end, I'll explain neural networks, which is kind of like a groundbreaking technology that's used in a lot of other fields in AI. So yeah, what is natural language processing? Natural language processing is anything that has to do with the human language. So this can be like giving Siri commands, Google Translate. If you're translating from Spanish to like English, that's an AI making that translation. The biggest thing is converting speech audio waves to text. So the way audio works is it's a bunch of like vibrations in the air. And so it's kind of hard to code something like that. And so we use artificial intelligence to kind of like make that decision with us. It actually involves neural networks as well. And the next subfield that I'll be talking about is computer vision. So like I mentioned, using like your face to unlock your phone, that's considered facial recognition. A pretty popular example is classification models. If you've ever kind of like come across classification models, you've probably seen an example of like cat versus dog. So here, if you feed in like an image of a dog, the model will predict that it's a dog. And so a more practical example that our research department is doing is called Bee Machine. So out in the field, bee researchers can upload images to our website, and it will identify what species of bees is actually there. And so this helps speed up their whole research process. The last topic that I'll get into is machine learning / deep learning. And so this is basically just a machine's ability to learn like a human using neural networks. And basically what it does is it picks up on patterns as you train it with data. It's used in a lot of other areas of AI, as I mentioned below. And so if you actually look right here, there's handwritten digits, and it's being passed through a neural network, and then there's 10 outputs that show you what number it's guessing that the number is being written. And so neural networks actually use a lot of multiplication and math that I'm not going to get into, but just to kind of give you an idea, that's what everything's going on right there. So yeah, the history behind neural networks. Walter Pitts and Warren McCulloch, researchers at the University of Illinois Chicago, took inspiration from the human brain in 1944. So they actually built the first neural network using electrical circuits. And if you don't know how neurons work, basically they just fire off other neurons to activate certain parts of the memory. And so we've kind of figured out a way to do that with the mathematical representation called artificial neurons. So how does it actually work? Deep neural networks have multiple layers, and each layer picks up on certain features. So subsequent layers combine those features from previous layers and then create their own features, and then the output at the end ultimately relies on all the previously activated neurons. So if you look at the picture, the first layer, as you pass it in an image, it picks up on like the edges of like your jawline, your lines of your nose, stuff like that. And then the next layer combines those edges to create like shapes such as your nose, ears, eyes, mouth. And then the third layer creates objects out of those shapes. And so at the end, you have like an ultimate output that like, say you have like, you're trying to identify like presidents or something. It'll combine those like objects and then say like, oh, this is like George Washington. So yeah. How does it actually learn these features? It goes through something called a training phase. So initially when you create your neural network, it guesses randomly. And you need to tell the model if it's right or wrong. And So as you pass in data, if you're telling it it's right, then it'll keep going with that guess. If you tell it's wrong, it adjusts its predictions, and so eventually it picks up on like patterns that will tell you if it's like a dog or a cat, etc. So yeah, where does AI end? Just to do a quick recap, I went over how AI is an umbrella term. I talked about natural language processing, computer vision, and neural networks. So AI is something we'll be seeing a lot in our lifetimes. Stanford professor Andrew Yang referred to AI as the new electricity during a conference in 2018. So if you think about like 100 years ago, like when electricity came out, it kind of revolutionized like the whole world. And so AI is actually kind of like something similar where it's being used in a lot of technology. So yeah, where does AI end?